Alright nerds, so let's talk about the particle model. Now, by the end of this, I want you to be able to understand the various states of matter, so solid, liquid, gas, in terms of particles. Now, this is your vocabulary, so make sure you write this down, pause the video now, write this down, and you'll have it to refer back to as we move along through the lesson. Now, the particle theory of matter is a theory that talks about how stuff is made up, and it's got the following laws, and these laws, when we put them together, make up the theory of matter. All matter is made up of extremely tiny particles, and that's best represented as little balls. And this is whether we're talking about atoms, molecules, big things, little things. When we're down to the particle size, they're still small, and we still consider them discrete little particles, which means separate. Each pure substance has its own kind of particle that's unique to just it, and it's different from other ones. So in other words, we can look at the particles themselves, or we can't look at them, but we can measure properties of those particles and work out which substance it's going to be. Particles attract one another. This is important. This means when they cool down, they'll stick together. Particles are always moving. Now we see it here. The liquid looks like it's moving about, and it is. It's moving about close to each other. The gas is moving all over the place. The plasma has just fallen apart. But the solid here doesn't look like it's moving, but what it's actually doing is vibrating in place. It's never still. It's always moving. It always has some energy, so it will always vibrate in place. Particles at higher temperatures move faster than particles at lower temperatures. All right, and this looks at, if we look over here at the gas, we can see that, right? The gas is sort of sitting there, like flying around the place, and gases tend to be hotter than they are when they're solids. So when they're a solid here, they're moving quite slowly, they're just vibrating against each other, it's not going very far or very fast. So let's have a look at the various states of matter. For example, in our table here, we've got the things we're changing, and then the three states, how it affects us. So the shape, in a solid, you have a fixed shape, okay, you see that here. In a liquid, it takes the shape of the container, and in a gas, it also takes the shape of the container. All right, so a solid will have its rigid shape, and liquids will take the shape of their container. With a solid, you have a fixed volume. It's the size of the chunk that it is. With a liquid, it'll be a fixed volume, and it will take up, the bottom of whatever container it's in. Whereas a gas, like a balloon, will fill up a container. It will spread so that it takes the size of the container. So it's both the shape and the size of the container. With a solid, we can't easily compress it. It's hard to squish a solid smaller. Same with a liquid. Liquids are hard to compress. Whereas gases, as we know, when we just sort of cup our hands together and push it together, we're pushing gas together. It's quite easy to push gas together. Expansion upon heating, a solid expands, a liquid expands, and a gas expands. Pretty much everything as we heat it up expands, and ability to flow. A solid will not flow, whereas both gases and liquids will flow. Now, when we talk about pure substances, we're talking about one type of particle, and each type of particle is able to go from a solid to a liquid to a gas. So, how does that work? Basically, as particles become more energetic, which means we've turned the heat up on them, so as we warm up particles, they move with more speed and force. Okay, so force is the push, right? And this is why a balloon expands, because the particles are moving with more speed and force, and they push against the particle, against the wall of the balloon, And here we see our different types of, on this diagram here, we see the different types of movements from one phase to another. For example, if we have something that goes from a solid to a liquid, we say it's melting. If you have something going from a liquid to a solid, we say it's freezing, and they both happen at the same temperature. If we've got something going from a liquid to a gas, we say it's evaporating, or from a gas to a liquid, we say it's condensing. But, and this is the really interesting point, so if we've got something which is moving from a solid to a gas, now if we have carbon monoxide, like dry ice, or carbon dioxide, dry ice, carbon monoxide, if we pulled that in the classroom, it would probably kill everyone. But carbon dioxide, dry ice, as we open that container, it sublimates, which means it goes straight from a solid to a gas. It skips the liquid phase altogether, sort of. It just moves through it really fast. So solid to liquid is heating up. Liquid to solid is cooling down. Liquid to gas is heating up. Gas to liquid is cooling down. Solid to gas is heating up. gas to solid, which we call resublimation or deposition, is cooling down. And in those times, we are changing the amount of energy. So we increase the energy to go from a solid to a liquid to a gas. And we decrease the energy to go from a gas to a liquid to a solid. And then there's plasma. That's what happens inside of like stars and fires and stuff like that, or TVs. Okay, so I hope that made a lot of sense. If you have any questions, put them in the comments below and we'll get back to you as quick as we can. Thanks for watching. Bye now.